Okay, this is the setup for the Sun, Earth, and Moon demonstration. And here, one of the things we can show about the Earth is the difference between day and night. And you can see that because the shadow is clearly at night. And then we can talk about sunrise and sunset. Okay. And then in this globe, got this camera so we can see what the people on Earth are seeing. Okay, from here. And so right now you can see the moon, and the moon looks to be about almost new. And one of the problems is, if we try to make the moon new by moving it here closer to the sun, the field of view of the camera isn't such that you want to say that, see right here the camera is right at the verge of sunrise, but you would be able to see it if you turn the Earth a little bit until you can see the moon. Because our field of vision is better than this camera's field of vision, you wouldn't get the sun for a little bit, for a few minutes, and then you would get this almost new moon shape. Okay. But while we're still talking about the Earth, we can talk about the seasons and how in the summer, for us in the northern hemisphere, because of the tilt of the Earth, which is conveyed by this the holder that holds the Earth at a tilt of 23 degrees, that's right, we can point out that the North Pole is always in sunlight in the summer. If this thing is pointed to the sun, that means that we're tilting in towards the northern hemisphere is tilting in towards the sun, and the southern hemisphere is always in dark. So that's the white nights up here and the months-long summer down here. As we go around the sun, and it's going to be probably hard for the kids to imagine this, but instead of walking this around the sun, because of everything plugged in, we have to kind of do it ourselves here. Now, at the equinox, when this thing is perpendicular to the sun is right over the equator, and so it's equally lit from the north hemisphere down to the southern hemisphere. And then you can go, I'm going to undo it this way so I don't twist my wire up. This is, for the northern hemisphere, the dead of winter, where this is lined up with the sun. You can see that the South Pole gets light all day, every day, and way up north, it's dark all night. And that's why our days in the northern hemisphere are shorter in the summer and longer in the winter. Days in this northern hemisphere are shorter in the winter and longer in the summer. I think it's probably best to use the equinox or the tilt perpendicular from the sun when we do the moon example, just because of the camera angle. So I'll move the moon over on the other side of the sun, and I might have to make it taller to make it more visible, but here I'm going to move the Earth. Let's see, move the Earth, or rotate the Earth. There's the moon, and it's probably best to do it right so that it's right on the edge, sort of the way we did it before, so that the camera is just at the cusp of day or night. And again, we can explain that the angle that the camera can see is different than the angle the the Earth can see, or that the humans can see. And so now here is the just after new moon, whatever that is. We'll figure out what that word is. And then we can move the moon, although we probably have to make it taller since we're inclined higher. I just used the fitting to make the moon higher. And now as we move the Earth into nighttime, see, since it's pointing higher because of the inclination, the moon shows up low. You can either move that up or closer. I guess you can do that too. Okay, and we can continue to move the moon around the Earth, talking about the orbiting moon around the Earth. And again, in the screen, it will appear to get fuller and fuller. Okay. I might have to move it closer so that it stays in the screen. But it's a full moon now, or it's close to full moon, and that makes sense because the moon is sort of lined up with the sun and the Earth. The moon orbits at an incline to the Earth a little bit, so that's why it's very rare for the moon to be in the shadow of the Earth, because they're not in the same plane. It does happen, but since it's 6 degrees tilted relative to the Earth's orbit, usually it's either above or below where the sun is. So, and then we keep turning. There's some tech tips on how to set up the camera and everything, but I think that it's a pretty good example. Even if the kids walk up to the globe and look at the Earth and the moon from the Earth's perspective, I think there's some value in that. It might even be easier for them to see it. The camera there. If we get too bogged down in the camera, it might take away from what the kids are learning about or can see even just with their own eyes standing next to the globe. So that's those are the things that we can talk about. We can talk about the tilt of the Earth and why that makes summer's the amount of sunlight day hours in the summer longer, because we spend more time facing the sun than we do in the summer than we do in the winter. Okay. Oh, my light source is higher than the plane of the orbit, mainly for safety, because it gets really hot. And so I want to keep it higher than the kids can reach. So, but then I want the Earth low enough so the kids can see. So there's a little bit of artificial angle from the light to the sun to the Earth. And the other thing we can show is when you do spin the Earth, you can watch the sun rise and set as it goes around, as the Earth rotates around the sun. And then the phases of the moon, and those are the real examples that we would use here for the Sun, Earth, Moon model. Oh, and also, I was hoping to make this to scale, and obviously it's not to scale, because we want the moon big enough to be able to see on the camera, and just having the real estate to do this. Maybe we should figure out exactly what the scale would be. The Earth would be probably half the size of this globe. All right.